So let's talk about resistor networks that are connected in parallel. So first off, what does parallel mean? Parallel means there's a it means that there's a branching off in the circuit and that the current can choose to go one direction or another direction. So in a resistor network looks like this.
The current comes in and then has a choice. It's going between the same 2 points, but there's 2 different roads that it can take.
All right? So basically, parallel networks consist of two separate circuits that are independent of one another. All right. So in parallel, so the potential difference between these two is the same because
they're the same 2 points.
There were just two different branches that went through. The current is going to add. So what we would say is that I1 plus I2 is equal to the total current I. I1 plus I2. All right. Now, as always, what we'd like to do is consider this parallel network as a single effective resistor. So I want the potential difference to be the same. Obviously, the current going in here into my effective resistor is going to be I. And so what we're going to do
is we're going to write the current as delta V over
the potential difference divided by the with of course our obligatory minus sign. So it'll be minus potential difference over R parallel equals minus potential difference over R1 minus potential difference over R2. Now, the potential difference is the same. So that means that that's going to cancel out along with the minus sign. And that gives us a formula for adding resistors in parallel. Over R parallel
1 over R1 plus 1 over R2.
So adding resistors in parallel is more complicated than adding them in series. When I add them in series, I just add. When I add them in parallel, what we say is that the reciprocals add. So 1 over the effective resistance equals 1 over R1 plus 1 over R2.